So yesterday we came up with the power rule, right? The power rule for antiderivatives. It's very similar to the power rule for derivatives, but instead of taking away a power, we add a power, and then whatever that new power, divide by it. That's the power rule. Okay? That's the power rule we've been using. So that's what we did yesterday. So today, what we're going to do is we're going to focus on trig. Okay? So just like derivatives of trig, there's antiderivatives of trig, right? So antiderivatives is just going in the opposite direction, right? If derivatives, you're going one way, antiderivatives, you're just going in the opposite direction. They're literally just the opposite direction. So I filled out one already. The antiderivative of cosine is sine because the derivative of sine is cosine. So it's just going in the opposite direction. Okay? So sine. What is the derivative of sine? Cosine. So what would the antiderivative of sine be? Negative cosine. Good. Negative cosine. Yeah, it's going to be negative. Always with the plus c. Why is it negative cosine? You guys are right. It is negative cosine. Why is it negative and not positive like number 2?
We're going backwards in the cycle.
Exactly. The cycle, right? The cycle of, let's see if I can find it from a long time ago. Mm-hmm. Let's see. Give me 1 second. Here we go. The cycle right here, right? Somewhere buried in your notes when we first talked about derivatives of trig, we made this cycle, right? To go to the right, to follow the arrows, if we're following the arrows, that's derivative, right? Now we're just going the back way. We're just going the opposite way. So from sine, the antiderivative of sine would be negative cosine. The antiderivative of negative cosine is negative sine. The antiderivative of negative sine is cosine. And then, like number 2, the antiderivative of cosine is sine. Okay? Okay, so secant squared of x. Secant squared. That sounds familiar. What is secant squared? We've seen secant squared before. Where have we seen secant squared? It's the derivative of tangent, right? So the derivative of tangent is secant squared. So what's the antiderivative of secant squared? Tangent. Tangent of x plus c. Cosecant squared. Cosecant squared. That's the derivative of what? Cotangent, right? So the antiderivative would just be the cotangent. Cotangent of x. Okay. Secant x tangent x. That's the derivative of?
Secant x tangent x. That would be secant.
Secant. Yeah, Arthur?
On number 4, secants, cosecants, whatever. On paper, it says the antiderivative that is negative cotangent.
Oh, negative cotangent?
Yeah.
So he's going to put negative there. Yeah, that's important. Yeah, definitely important. Negative cotangent. Okay. And then the last one, cosecant cotangent. The derivative of cosecant cotangent is cosecant. So the antiderivative would be cosecant of x. Okay? No big secret there. There's not, it's just the opposite direction. Negative. Okay? That's just straight off your sheets. And I believe, let's see if I have the same one you guys do. These are actually up there, right? 1 through 6 is actually on the bottom part here. If I have the same one as you guys, it starts with number 6, 6, 7, 8, 9, 10, 11, and 12.
11 we didn't do. Then that goes to 13, 14, 15. Okay. So yeah, so now we're going to start using the bottom part. Now we're going to start using the bottom of your sheet. Top is for derivatives. The bottom is for antiderivatives. So it's just like a quick. There's not as many because there's not as many rules in antiderivatives. Power rule is one of them, and like I said, the other one is U substitution, which we'll talk about next week. Okay. Okay, so here we go. Let's start doing some antiderivatives now. Okay, so the antiderivative of 4 sine of x dx. Remember, the dx is just there for show right now. There is a purpose for a dx, but we'll talk about it tomorrow. I'll tell you what the purpose of that is tomorrow. But for right now, so 4 times, right? Well, I can use that rule. Rule number 5, right? It's 5 is a coefficient, or 4, whatever the number is in front of sine, is a coefficient. So I can just move that to the front. So it's 4 antiderivative sine of x. So the antiderivative of sine of x is negative cosine. Plus c. Negative 4 cosine x plus c. Okay. Number 2. So number 2. There's first of all, there's a fraction, right? It's a fraction or division. We don't have a quotient rule, so we can't use quotient rule. And there's a cosine squared, right? There's nowhere, we don't have cosine squared on my list, right? There is no cosine squared. So we got to think outside the box here. What can we change this? What changes can we make to this so that we can use the ones we have? So we can use our trig rules. There's a couple changes we can make. What's one change we can make?
Maybe turn the fraction, maybe we can turn 6 over cosine squared of x into 6 times cosine of x to the negative 2.
That's the first step. So first step is separate them. 6 times 1 over cosine squared of x. That's the first step. Now 6 is just a coefficient like 4 was in the last problem. So we can move it to the front. So 6 That's the first thing I would do. So don't have to worry about 6 anymore. What about 1 over cosine squared?
Is that the equivalent of secant squared?
That's secant squared, right? 1 over cosine is secant. Secant is 1 over cosine. So 1 over cosine squared is the same thing as secant. So essentially, it's this question here. And secant squared is on my list. The antiderivative for secant squared is tangent. So it would be 6 times tangent of x plus c. Okay. So even if it doesn't make complete sense, try to move things around, see what you can do, because it will be on the list. There won't be a time unless, for right now, when we get to U substitution, that's a different story. But for right now, there won't be a time where I give you something that's not on the list. Now, it might not be on, like cosine squared isn't on your list, but you can change it so that it is. You can, I don't want to say change it, because I didn't change it. I just kind of manipulated it a little bit, right? Because 1 over cosine squared is secant squared. I didn't change it. I didn't straight up just change it. but it's just kind of your substituting, I should say. Substituting would be a better word. Okay. So now you have, I got to find the antiderivative, 9 cosine of x minus 4 sine of x. Well, this minus in here, I'm going to separate them. So now I have 2 smaller problems. You can do that. Rule number 4 said you can separate them. If you're adding or subtracting 2 separate functions, you can do that. It's the same rule with derivatives. You can do that as well. So now I just have 2 smaller problems. So we have 9 times the antiderivative of cosine of x minus 4 antiderivative of sine of x. The antiderivative of cosine is sine. And then the antiderivative of sine is negative cosine, right? So negative cosine means that would become positive, plus c. Okay. Try number 4. Try number 4. Number 4, kind of think like number 2. Number 4, you're going to think like number 2. That kind of thinking. You need to substitute some things in before you can find the antiderivative. Okay, so for this one, we have to do some substituting, separating, because it's a fraction, first of all, so we can't use quotient rule. We don't have a quotient rule, so we kind of have to do what we did in number 2. Okay, so the way to do this one is you're going to separate the top from the bottom. But, so cosecant, right? So in other words, another way of writing this, not cosecant, sine and cosine. Another way of writing this is like that, right? The bottom is cosine times cosine, right? The top is just sine of x. So what I actually am going to do here is I'm going to do this. I'm going to say sine of x times one of those. And then I'm just going to, the other one I'm just going to have by itself. The reason I did that is because what is the relationship between sine over cosine? It's tangent, right? It's tangent, right? So that negative there, you can move it to the front or you can leave it in there. I know sine divided by cosine is tangent. So what I'm going to do here is I'm going to move the negative in front. Because it's really just negative 1. So now you're going to change sine of x over cosine of x to tangent of x. And then 1 over cosine is secant. And if you go to your sheets or you look on these notes, that's one of ours, right? It's just in the opposite order. It's secant x, tangent x, right? And what's the antiderivative of secant x, tangent x? Secant x. So it's negative 1 times secant of x plus c, or just negative secant x plus c. Okay, sometimes you got to think out of the box. It's problem solving, just critical thinking, right? Not everything looks the same. Not everything looks the same. Every job you guys will have to do critical thinking. It doesn't matter if you're a mechanic or you're a brain neurosurgeon, right? You have to do critical thinking. Not every car looks the same. Not every brain looks exactly the same. You got to kind of think. You got to kind of think. That's what's called problem solving. Okay. I'm not saying you got to get it right every time, but just not be afraid to do that. Not be afraid to do that because sometimes that'll happen. Okay. All right. Okay. So last thing, and then I'll give you the rest of the time to start on your assignment. Last thing. Good. Okay. Okay, so it says solve the following differential equation. We've never really seen that. We'll see it later in the semester, but what differential? Differential kind of sounds like what? Derivative, right? Differentiation derivative. That's what it is. It's just a derivative equation. Differential equations are a fancy way of saying derivative equations, right? That's f prime. Okay, so solve that with the given conditions. So they say the derivative is 3x plus 1. Already done. And then f of 2, so if I plug in 2 to the original, I'll get 3 as an answer. So what they want you to do is come up with the original, f of x. Right? They want you to come up with f of x. So, antiderivative, right? What we got to use, that means we got to find the antiderivative of 3x minus 1. That's the first thing we have to do. To get f of x, you got to find the antiderivative of f prime. That's just power rule. So we're going to add 1 to the power, divide by the new power. Okay. So 3 over 2x squared minus x, or minus 1x, plus c. That's where we've stopped. But they're saying they're giving us a little bit more of information. So we have f of x right now. F of x is that guy there. They said, hey, when I plug in 2 to f, I'll get 3 as an answer. So let's plug in 2 for f. Okay, so I'm going to plug in 2 to f. I already know what I should get as an answer. 3. It said I should get 3 as an answer. So I simplify. So 3 over 2 times 4 minus 2 plus c. So the 4 and the 2 cancel out. So I get 3 equals 6 minus 2 plus c. Now we can solve for c. C is going to be, looks like negative 1. So now I know what c is, so I can go put c back in. So my answer is the original. But instead of c, I know what c is this time because they've given me that. Usually they don't give you that, but they have. Okay. B is the same type. B is the same thing. You just start, now you're going to start with the second derivative. So I want you to try that one. So you start with the second derivative, find the first derivative, find the original using antiderivatives. So you just have, it's another layer, but you're doing the same thing for letter B. You're just starting with the second derivative.
we start with the second derivative,
Mhm.
we go for if it's something x plus c, right?
Mhm.
And then if we, then we go to the first derivative, would that become plus cx or?
No, so plug in. So once you find the first derivative, right? So the first derivative's not too bad. The first derivative is just going to be 2x, right? Then it says, hey, when I plug in 4, when you plug in 4 to the first derivative, you get 0. Oh, I forgot my plus c. That's the first thing. When you plug in 4 to this guy here, you should get 0 as an answer. So then I got to do that. So 0 is an answer, so plug in 4. So the first derivative is actually 2x minus 8. Now, use that to find the original. Okay. So use the second derivative to kind of build the first derivative. You know a value. You know 4. When I plug in 4 to the first derivative, I'm going to get 0 as an answer. So we found that c is equal to negative 8. So then I was able to finish the first derivative, 2x minus 8. And then you do the same thing, antiderivative. And then it said when I plug in 4 to the original, I should get negative 1 as an answer. So I did that, and I was able to find that c is equal to 15. And you're done. That's the original. Okay, I was able to build the original. Okay, so same thing, just they give you, you're able to solve for c. Most of the time you're not able to solve for c, but this time you were because you were given that information. Okay, all right, so I'm going to give you the rest of the time. So we got about almost 30 minutes to work on the practice.
So there's a dy in the, when we find the answer.
So which one? You're looking at one specific?
Would it be the same thing as dy?
Yes. Yeah. So yeah. So look at number 3 on your homework.